Welcome to the Explainer. Today we're decoding ISO 26262. Now that might sound pretty technical, but it's the critical safety standard working behind the scenes inside your car, protecting you from all the complex electronics that are running the show these days.
All right, so here's our game plan for today. We're going to start with why we even need something like this. Think of your car as a computer on wheels. Then we'll get into the global safety rulebook itself. We'll break down how it rates risk with something called ASILs, look at the entire life cycle of safety, and then wrap up by looking at what this all means for the future.
Okay, first up, a computer on wheels. To really get why this standard is so important, we have to start with the cars we're driving right now. I mean, let's be honest, they're not just mechanical machines anymore, not by a long shot. So, that brings up a really big question, right? Your car has millions of lines of software code. So how do we make absolutely sure the code controlling your brakes doesn't have a bug? Because we're trusting these invisible systems with our lives, and a single mistake in that code could be the difference between a normal stop and, well, something much, much worse.
And that's really the heart of the issue. Our cars are getting smarter and smarter. You've got advanced driver assistance, sensors everywhere, and all these little computers managing everything from the engine to your windows. But with all that complexity, the risk of something going wrong with those electronics also goes way up. And that's exactly the problem ISO 26262 was created to solve.
So, you've got this huge global industry. We're talking giant car companies, tiny part suppliers, everybody in between. How do they all get on the same page to tackle this problem? Well, that's where the Global Safety Rulebook comes in.
And that rulebook is ISO 26262. All it really is an international standard for what's called functional safety. And that's just a fancy way of saying, let's make sure the electronics in our cars do what they're supposed to do and don't create any crazy risks. It's actually adapted from a more general safety standard, but this one is built specifically for the car world.
Now, what's really interesting is that this isn't some dusty old rulebook sitting on a shelf. It's constantly evolving. It officially came out in 2011, but by 2018, they'd already done a major update to include things like semiconductors. You know, the tiny chips that are basically the brains of our cars, and they even brought motorcycles into the mix. So it's always playing catch-up with technology, which it has to.
Okay, so how does this standard actually work? To get that, we need to talk about its core concept, which is how it rates risk. It's a system called ASILs, and honestly, this is the heart of the entire standard.
ASIL stands for Automotive Safety Integrity Level, but you can just think of it as a risk rating. It's a way to figure out how critical a system is for your safety. For example, the software that runs your car radio, not very critical. But the system that controls your airbags or your brakes, yeah, that's a whole different story.
So how do they come up with this ASIL rating? Well, it's not random. It comes down to answering three basic questions for any potential failure. First, severity. If this thing fails, how bad could the injuries be? Second, exposure. How often are you in a situation where this failure could even happen? And third, controllability. If it does fail, can the driver actually regain control of the car? It's a really logical step-by-step process.
And you can see here exactly how that plays out. You combine those three factors. If the impact is high across the board, we're talking life-threatening injuries, a very common situation, and it's super difficult to control. Boom, you get an ASIL D. That's the highest risk level. On the flip side, a minor problem gets an ASIL A, the lowest risk.
And this is so important, because that letter grade, A, B, C, or D, changes everything. It dictates how rigorous the safety process has to be. If you have an ASIL D system, you have to throw the book at it. We're talking redundant backups, way more intense testing, independent code reviews, all this extra stuff that you just wouldn't need to do for a lower-risk ASIL B system.
So you see, that ASIL rating isn't just some sticker they slap on at the end. It kicks off a whole process, a blueprint that has to be followed for the entire life of that component.
And I mean a complete blueprint. The full standard is huge. It's broken down into 12 different parts. This isn't just some last-minute checklist. It covers the entire product lifecycle.
And when we say lifecycle, we mean from cradle to grave. It's all about making sure safety is baked in from the very beginning. So it starts with the concept phase, before anything is even built. It goes through the development of the system, the hardware, the software. Then it covers production, what happens when the car is on the road, and even service, and what to do when the car is finally decommissioned. It's a true end-to-end process.
Okay, so we've got this massive process.
But how do car makers actually prove they've done all this? How do they show that a car is safe enough for the road? That brings us to compliance and certification.
And this is a really key difference. Think of it this way. Compliance is when a company does a self-evaluation. They're basically raising their hand and saying, yep, we follow the rules. But certification is when an independent third party, an expert group like TÜV Nord, comes in, goes through everything with a fine-tooth comb, and gives it their official stamp of approval.
So, for a car maker, which one do you choose? Well, it's a big strategic decision. Certification gives you a much higher level of credibility. It's solid proof. But as you can imagine, it's also a lot more work, and it costs more. So while compliance is one thing, certification is really seen as the gold standard.
And this quote really nails why all of this is more critical now than ever. The technology in our cars is just evolving at an incredible pace. So having this shared, super rigorous framework for safety, it's not just a nice-to-have anymore, it's absolutely paramount.
And that leaves us with one last big question for the future. We've already seen the standard evolve to handle things like semiconductors. But what happens when cars become fully autonomous? As we get ready to hand over total control to an AI driver, how does a standard like this have to change to keep us safe then? In the end, for the self-driving car of tomorrow, this safety rulebook might just be the most important feature it has.